The power rule states that the derivative of x to the power of n is n times x to the power of n minus 1. If we take the limit of x to the power of n, we get x plus hn minus x to the power of n over h. If we expand the function, we get x to the power of n plus n choose 1x to the power of n minus 1 times h, where the binomial factors come from Pascal's triangle, obviously, plus n choose 2x to the power of n minus 2 times h to the power of 2, and so on. At the very end, there is n choose nx to the power of 0, h minus x to the power of n, and then you have to divide everything by h. The x to the power of n's cancel out, and when you divide everything by h, you get n choose 1x to the power of n minus 1, plus the next term, and so on. The last term is n choose 1x to the power of 0. Replace the h's with 0, and you're left with n choose 1x to the power of n minus 1, since everything else becomes 0. N choose 1 is the same thing as n factorial over 1 factorial times n minus 1 factorial, which can be factored out to become n times n minus 1 factorial over n minus 1 factorial times x to the power of n minus 1. Once you cross these out, you get n times x to the power of n minus 1, which is the power rule. However, this only proves positive values of n. If you want to prove negative n values, you need to use logarithmic differentiation. Start with y is equal to x to the power of n, then take the ln of both sides. Simplify, then take the derivative of both sides. Multiply both sides by the y value from the original equation, then simplify. You should get nx to the power of n minus 1, which is the power rule. In this proof, n can be negative or positive. To prove that differentiation implies continuity, you need to use the definition of continuity, which is that an existing limit of a point is equal to an existing value at that same point, and the definition of derivative at a point, which is f of x minus f of c over x minus c, which is equal to the f prime of that point. With the second function, you can multiply limit of x minus c to both sides and expand f prime of c. You can expand the right side by taking the limit as x approaches c of both terms. The limit as x approaches c of x minus c is just going to be 0, so you can just simplify the other term, multiply them together, and get 0. So now you have the limit of f of x minus f of c is equal to 0. You can expand the limits, then add limit of f of c to both sides. Now you have limit of f of x is equal to limit of f of c. The limit of f of c as x approaches c is just going to be f of c, and when you put it together, you have the definition of continuity. Some common mistakes with power rule are taking the derivative of a different variable. This does not equal 3y squared. You need to use chain rule for these kinds of problems. When you take the derivative of multiple terms exponentialized, you cannot use the power rule. You have to use the chain rule for these kinds of problems. When you take the derivative of a number to the power of x, you cannot use the power rule. You must use logarithmic differentiation or you will lose points. One common mistake with continuity is thinking that continuity implies differentiability. This does not work both ways. Continuity does not imply differentiability. First, you have to convert the roots to fractional exponents to make it easier, then multiply the exponents out. After that, you have to take the derivative of both sides. By power rule, you can bring the exponents to the front and subtract each exponent by 1. To simplify the negative exponent, bring it to the denominator. Then add the second term and then you're done. That's the derivative. 1 over 5x to the power of 4/5 plus 10x to the power of 3 over 2. The second problem is really simple. Even though the function is continuous, the derivative does not exist since there is a corner at x equals 1. Again, just because the function is continuous does not mean it's differentiable.